My name is James. I'm from Nigeria originally. I moved to Canada at a young age when I was 16. I first learned about bioremediation in 2009 during my undergrad. I did quite a bit of research into bioremediation at that point. I got involved in Delta Remediation in 2015. I found my niche in bioremediation. That was the niche where I could make an impact. We have worked with 4 Canadian universities and received research grants from the National Research Council of Canada. Early on in our research, it was clear that Pseudomonas microbes had a strong affinity for complex hydrocarbon chains, resulting in the development of Biologics 2XP, which is a Pseudomonas-based technology that is stable and can be stored at room temperature. This allows Delta to tackle complex remediation projects in remote areas and overseas. Biologics has been successfully deployed on over 200 sites in multiple countries with a 100% success rate.
My title at Delta Remediation is molecular biologist. My role is to conduct research and apply that research to the field, taking science and taking the tools from microbiology for biologics and using it to solve issues in the real world, like hydrocarbon contamination and other complex chemical issues.
A lot of our competitors are basically earthworks companies. They have lots of yellow iron and lots of laborers and welders, but they don't have scientists. And then on the other side, some of our other competitors are lots of scientists and white coats that develop great things, but they have no idea how to actually take those great things that have been developed and implement them in the field. So they're always relying on somebody else to take their tech and apply it. We have developed something that other people are buying and using aside from us. We're still our best customer, but being able to create that feedback loop from our field crews saying, hey guys, could we do this to the process, or could we do this to the product? We're able to actually incorporate that in our research winter months so that they can, we've had a continuous improvement for the next summer.
What sets Delta apart from the competition is our dedication to continuous improvement. Developing our own bioremediation product was only the first step. Rob and I knew from day one that the bacteria were growing as soon as we mixed them with water. We also knew that we could improve environmental conditions to maximize the growth curves of biologics bacteria. But in order to maintain our high standards of quality, we needed to develop a way to quantify the microbial population in real time. With Delta's Bioreactor called Regrow 2, we can do exactly that.
The bioreactor is essentially a large tank. We developed a bioreactor that's got 3 components. So we have the tank component, which can be sourced locally. For a job like this, we actually brought our own tank, but if you have to take a ship or something, if the client has a tank on site, we can take any tank. We can add an aeration unit to stir and aerate the tank. So that's the mechanical component, and then we have an instrumentation component, which is the fluorescence spectrometer and different probes that we use to check pH, dissolved oxygen, and of course the fluorescence of the bacteria. I've known for years that the bacteria are growing in the solution and we should just grow them on site rather than having to have so much powdered product. And so over the last 2 years, we've been working with a fluorescence spectrometer to be able to grow the bacteria in liquid form. So for the last 4 days, we've actually been growing a batch of 10,000 liters of bacteria that will continue to grow throughout the project. So we'll always be adding additional bacteria so that we're actually not varying so much from what we've done, but we're also providing this new biologics regrowth technology as an addition. We always knew that when we were culturing bacteria on site that they were growing, but unlike cattle in a field, we had no way to count them in real time. Industry typically uses standard plate count analysis, which takes 24 to 48 hours for your results, which is great, but when you're in the field doing projects, we need data now. And this tool has allowed us to do just that. It gives us real-time population data so that we know when our populations are high enough to be entered into the ecosystem through injection systems or mixed into the soil through one of our ex-situ bioremediation processes. It's quite simple. Obviously, I can't see the screen here. Basically hold our biologics solution, and it looks like water to the naked eye, but when you put it into the spectrometer, and get a reading, it'll actually produce a wavelength. It'll actually tell us in a ppm level how many microbes we have. So it's really taken all the guesswork out of growing microbes on site, and it's allowed us to really move forward with the regrowth bioreactor, which is going to change the name of bioremediation. It's going to allow us to create a more efficient solution at a more economical price. Bioremediation is already known as one of the more cost-effective on-site remediation strategies, and innovations like this is just going to continue to drive it to make us more efficient, more economical, creating more value for clients, hopefully growing the business and keeping more soil out of landfills.